Hello, everyone. This is Dr. Imani speaking. We're going to start today to answer questions for a state of matter, separating techniques, and atomic structure and bond. Let's start. For paper 2, which is multiple choice paper, in which change do the particle move for the report? For the report means from solid to liquid to gas. So from solid to liquid and liquid to gas, from Z and Y, so Z and Y. Second question, diagram X, Y, and Z represent the three states of matter. Which changes occur during boiling? During boiling process, liquid changed to be gas. So liquid, which has Y, turns to be gas, which is Z. So Y to Z. And then which change of a state takes place during evaporation. During evaporation, liquid turns to gas. So liquid to gas. And then in which process do particles move closer together but remain in motion? Particles can move in liquid state and in gas state. Move closer means liquid, so condensation process. From gas to liquid, but remain in motion, okay? So particles move slowly in liquid, but fast in gas. The changes that occur when substance changes state are shown below. So which process W, X, Y, and Z is occurring in the following four situations? Butter melts on a warm day. Butter is a solid, turns to liquid, and water condenses on cold surface. So water condenses from gas to liquid. The volume of liquid ethanol in an open beaker reduces, so evaporation from liquid into a gas. Then ice, which is solid, forms inside freezer. So from liquid to solid, which is freezing. So number one, from solid to liquid. Where is from solid to liquid, which is W? So C and D are incorrect. So A or B. Then second one, from gas to second one, gas to liquid. Yeah, so gas to liquid, which is Y. So answer is gonna be B. Then the diagram shows the sugar lamp and cube of tea. Which two processes must happen to spread the sugar eventually in the tea? So first, dissolving, so no diffusion, no melting, so dissolving, then diffusion. So answer is going to be B. And then a gas jar of bromine vapor and a gas jar of air are set up as shown in diagram 1. The glass slide is removed. Diagram 2 showed the appearance of gas jar after 1 hour. Which statement explains why the bromine and air mix together? So bromine is denser than air? No. Bromine is lighter than air? Incorrect. Bromine molecule move upward and molecule in air move downward? Not correct too. Molecule of bromine and air move randomly in all directions. Diffusion occurs in all directions, not moved only upward or downward. The diagram shows a cup of tea. Which row describes the water particle in the air above the cup compared with the water particle in a cup? So, in air above the cup, so moving faster than liquid or than particle inside cup. So moving faster, not C and not D. Closer together, which is incorrect. So answer is going to be B. And then the diagram showed how the molecule in the exhausted gas diffuse into the air. Which statement describe what happens to this molecule next? So the molecule fall to ground because they are heavier than air? Incorrect. The molecule go back together as they cool? Incorrect. The molecule spread farther into air, which is correct one. Show in figure. Then, next question. Substance X can occur in 3 different physical states as shown in diagram. Which statement is correct? In state 1, particle vibrate in a round fixed position. Incorrect. Liquid, which is 1. 2 is a gas. 3 is solid. So diffusion occurs in the phase change from 1 to 2. Diffusion occurs from 1 to 2. It's okay. But 1 to 2, not diffusion. Or diffusion occurs in 1 and 2, but not from 1 to 2. The volume of substance in 3 is a fixed position. Yes, it's correct. And then the formula of methane and formula of ethane. Methane is the CH4 and ethane is the C2H6. Which row describe diffusion and relative rate of diffusion methane and ethane? Methane lighter than ethane, which is heavier because more number of carbon and hydrogen. Description of diffusion. Particle move from a high concentration to low concentration, correct. So A and B correct, but C, D incorrect. Particle in diffusion move from higher concentration to lower concentration. Relative rate diffusion. Ethane, which is heavier, diffuse more quicker, incorrect. Diffuse methane, which is lighter, diffuse quicker. Okay. This is a very tricky question. A mixture of ice and water is left to stand and the ice melts. Which row describe what happens as the ice is melting? Ice is solid, melting, converts into liquid. So the temperature of the mixture stays the same. This is an example for heating process from solid into liquid. At this region, temperature remains constant and energy increase because energy used to overcome forces of attraction between particles. So answer is D. Stay the same, temperature does not change, but only energy increases because used to overcome forces of attraction between particles. And then complete the table about solid, liquid, and gases. In solid, particle separation, which is touching, touching, and the particle arrangement in liquid is irregular, yeah, and in gas, type of motion, random, very fast and random, freely in all direction. The graph shows the change in temperature as a sample of a gas is cooled. Name of the change state taking place between A and B. A and B is condensation. So condensation process occurs. This is a cooling curve, not heating curve. First level of condensation, second level of freezing. A bottle of liquid perfume, underline keyword is liquid perfume, is left open and at the front of a room. After some time, the perfume is smelled at the back of room. So name 2 physical process taking place. First, the process evaporation, then diffusion. So evaporation first, converted into gas, from liquid to gas, and then diffuse from higher concentration to back of room. Then, very tricky question. One difference between boiling and evaporation is the rate at which the process occurs. State one other difference between boiling and evaporation. Take care. Boiling occurs at exact temperature or fixed temperature, but evaporation occurs below boiling point or on only for particle on the surface. So the boiling occurs at fixed temperature. Evaporation occurs only for molecules that on the surface and occur in region or in range, not fixed point. Description of separation, arrangement, and motion of particle element X in a solid state. So in solid state, separation just touching, tightly packed, accepted. Arrangement, regular. And motion, vibrate at fixed position. At fixed position. Then, very tricky question. The graph shows how the temperature of substance changes as it cooled over a period of time. So this is cooling curve. Remember, first level of is condensation, second level of it will be freezing. So before condensation, it's going to be gas. After condensation, it's going to be liquid. After freezing, it's going to be solid. Each letter on graph may be used once, more than once, or not at all. So which letter S, T, V, W, X, Y, and Z shown when? The particle in the substance has the most kinetic energy. Most kinetic energy mean highest temperature. Highest temperature for S. So answers will be S. The particles in substance are farthest apart. Farthest apart means in gas. In gas with the highest temperature. So it's going to be S. S. The substance exists as both gas and liquid. In gas and liquid during condensation, which is V. At this point, particle, gas, and liquid exist at the same time. So it's going to be V. Use the graph to estimate the freezing point of this time. Freezing point equal to the melting point in heating. So second level of, just make a line and estimate it, which is going to be 140, 135, accepted in range like 135, 130, 145 accepted, 135 for example. Name the change of a state directly from solid to gas. From solid to gas, it's going to be sublimation. Sublimation from solid into gas. And then, next question. Element X can undergo the following physical changes. Give a scientific name for each of the numbered physical change. Remember, physical change can be reversed. No new substance formed. So, first one, which is one from solid to liquid. Solid to liquid is melting. And number two, gaseous to liquid, which is condensation. And number 3, from liquid into solid X, which is freezing. And number 4, from solid to gas directly, which is sublimation. Okay. Explain why the changes shown are physical change, no new substance form. No new substance form. Okay. So one difference between boiling and evaporation, we did it before. So the rate at which a process occurs, and so boiling occurs at fixed temperature but evaporation occurs at any temperature or below boiling temperature. Accept. Then describe the separation, arrangement, and motion in solid state. We did it before. Same idea, so skip it. Then, when colorless gas, hydrogen bromide and ethylamine come into contact a white solid form. This is a diffusion experiment. So two gases diffuse to form white solid. The following apparatus can be used to compare the rate of diffusion of the two gases, ethylamine and hydrogen bromide. The following apparatus can be used to compare the rates of diffusion of the two gases, ethylamine and hydrogen bromide. Remember, HBr, mass of HBr, because diffusion depends on temperature and mass. From periodic table, hydrogen equal 1 and bromine equal 80. So overall mass for HBr is 81, 1 plus 80. And for ethylamine, from periodic table, you can calculate mass. So 12 plus 3 multiply 1 plus 12 plus 2 multiply 1 plus 14, which is for nitrogen, plus 2 multiply 1. So 2 plus 14 plus 2 plus 12 plus 3 plus 12. It's going to be 45. It's going to be 45. So which one is heavier? Hydrogen bromide is heavier than ethylamine. So HBr diffuse slower than ethylamine. Ethylamine diffuse faster at the same time. So white smoke is going to be at C. So answer it will be C, because hydrogen bromide is heavier or has a larger mass, so diffuse slower. So it takes more time, travel less distance. What is a diffusion? Diffusion means random movement of particles from higher concentration to region with lower concentration. Okay. What property of gas molecule affects the speed of diffusion? Speed of diffusion. Property in gas, which is mass or MR, molecular mass. Then, some questions for separating techniques. We did questions for states of matter, which is very simple topic. For separating techniques, an important aspect of chemistry is purity and method of purification. Give an example substance used every day in life. Must be pure, like water, like drug. Then, list of techniques used to separate mixture is given below. Chromatography, crystallization, diffusion, and evaporation, filtration, fractional distillation, and sample distillation. From the list, choose the most suitable technique to separate the following. How to obtain water from seawater. How to obtain water from solution. Seawater is a salt plus water dissolved, so to form solution. So to obtain water, water is a key word for distillation, which is simple distillation, not fractional distillation. Simple distillation. Okay, simple distillation. So if you want to obtain water from seawater, seawater is already solution. To obtain water from solution using simple distillation. Helium is a gas. From mixture of gases, helium and methane are gases. So by using diffusion, okay, different mass diffuse with different rate. Ethanol from mixture of ethanol and propanol. Take care. Ethanol and propanol liquid, miscible liquids with different boiling point. To separate ethanol or liquid from miscible liquid with different boiling point using fractional distillation. Using fractional distillation. Iron filling from mixture of iron filling and water. Take care. Most metals are insoluble in water. Okay, so iron filling from mixture of iron and water. So that means mixture, not solution. I mean insoluble. By the way, solution is mixture. But solution, solute, dissolve in solvent. But iron filling and water, this is the key word, and means insoluble. So if iron dissolve in water, the word will be iron solution, okay, or aqueous iron. But iron and water means insoluble. This is a very important, tricky point in exam. So using filtration. Insoluble substance separate from each other by filtration. A mixture of two amino acids, glycine and alanine. By the way, this is a key word for chromatography. To separate amino acid or separate sugar or separate dyes from mixture together. So using chromatography. This is key word for chromatography. Describe how you would obtain pure sample of copper 2 sulfate 5 water crystal from the mixture of copper 2 sulfate water with copper oxide. Remember, copper sulfate with water crystal means form water after drying. So that means copper 2 sulfate is already soluble in water. Copper oxide, which is insoluble. So most metal oxide insoluble in water. So using this technique. Add water to the mixture and then mix by glass rod. Then filter and take solution. Solution is for copper sulfate. And then heat solution till crystals start to form. So crystallization process occur now for solution to obtain crystal or solute as a crystal form. Leave it to cool and then filter and wash with pure water or distilled water, then dry crystals between two filter paper. So first, separate copper 2 sulfate from copper oxide by filtration after adding water, then do crystallization to obtain crystal of copper 2 sulfate 5 water. Another example. From this list, diffusion, filtration, fractional distillation, simple distillation, crystallization, and chromatography. From this list, choose the most suitable technique to separate the following mixture. Butane from mixture of propane and butane. Okay, remember, propane and butane are gases. So to separate gas from mixture of gases using diffusion. Okay? So oxygen from liquid air, which is very tricky question because oxygen usually is gas at room temperature. From liquid air means air compressed to be liquid or in very low temperature. So how to separate oxygen from liquid air? Liquid air is a mixture of liquid. To separate oxygen from mixture of liquid, use fractional distillation. And then water from aqueous magnesium sulfate. Aqueous, which is the key word for, means magnesium sulfate is already soluble in water. To separate water from solution, aqueous means you have already solution. Aqueous, magnesium sulfate. If aqueous, then name of compound, so that means this is a solution. So to separate water from solution using simple distillation. Okay? Potassium chloride from aqueous potassium chloride. So aqueous potassium chloride, which is soluble in water. To obtain potassium chloride, which is solute using crystallization. And then silver chloride from mixture of silver chloride and water. Mixture of silver chloride and water. So silver chloride is already insoluble. How do you know it's insoluble? So silver chloride and water, no aqueous silver chloride or silver chloride solution. So that means silver chloride is insoluble in water. So using filtration. Glucose from mixture of glucose and maltose to separate sugar or simple sugar mixture using chromatography. So sugar or amino acid, okay, dyes, keyword for chromatography. Then the following techniques are used to separate mixture. Simple distillation, fractional distillation, evaporation, diffusion, chromatography, filtration, and diffusion. So from the list, choose the most suitable technique to separate the following. Methane from mixture of gases. To separate mixture of gases, use diffusion. Water from aqueous magnesium sulfate. Water from solution, which is simple distillation. Glycine from mixture of amino acid. Keyword for chromatography. Iron filling, which is insoluble in water by filtration. Zinc sulfate crystal from aqueous, mean already zinc sulfate dissolved. So just to obtain it again as a solid, use evaporation or crystallization, the same meaning. Hexane from mixture of liquids using fractional distillation, mixture of liquids. Then, paper chromatography can be used to separate mixture of amino acids. The apparatus used is shown. So, chromatography, this is a chromatogram paper, baseline drawn in pencil, and solvent line should be below baseline so that a spot does not dissolve in whole solvent. Why should the baseline drawing in pencil? Pencil is insoluble, so does not interfere with spot color. So baseline must be drawn in pencil, which is insoluble in water. Why the separation of amino acid is complete, the chromatography paper is sprayed with locating agent. By the way, locating agent substance is sprayed to make invisible spot to be visible. So some spots may be colorless. How to identify the spot? Identify the spot by calculating the RF or measure the RF. So It makes invisible spots to be visible. Then the diagram shows the chromatography paper after it has been sprayed with locating agent. Now, spot shown figures, our chromatogram paper. So calculate the RF. By the way, RF is a distance traveled. Okay, this is the RF value. Distance traveled by spot divided by distance traveled by solvent, but starting from baseline to the solvent front. This is distance traveled by solvent. And distance traveled by spot S, for example, measure from baseline to S by using ruler. So this is a 3.5 centimeter, and this is a 2.5 centimeter to calculate RF distance traveled by spot from baseline to the spot, divided by distance traveled by solvent, which is from baseline into solvent front. Remember that. Then, is used to separate mixture of liquid with different boiling point. So, fractional distillation. Is used to separate mixture of amino acid. Key words for chromatography. Then chromatography can be used to test the purity of substance. Remember, if substance is pure, only one spot shows in diagram. The diagram shows the chromatogram of colored substance. Start line, solvent line, and two spots. One of them is X. How does the chromatogram show the substance is not pure? If pure substance, so only one spot shows in diagram. For example, F is pure, X is pure, so only one spot in paper chromatography. So two spots means impure. So your answer is going to be two spots shown in diagram in paper chromatography. And then draw the circle around RF value for X. So first measure distance traveled by solvent from the start line into the solvent front. Then measure distance from baseline or solvent line into the X. So 3.8 divided by 4.7, which is going to be 0.8. So answer will be 0.8. By the way, RF value always less than 1. Always less than 1. Remember, this is a very tricky point. Spot shows in the bottom or travel small distance means less soluble in solvent, but substance shows the travel long distance means more soluble. So for example, if this is Y, so Y less soluble than X. Why? Because X travel farther. Show how colored substance can be made visible in chromatogram. So locating agent, if color is used or spray, locating agent to be visible 1. And chromatogram can be used to identify simple sugar in a mixture. Student analyzed a mixture of sample sugar by chromatography. All the sample sugar is a mixture where colors. What is the name given to the type of substance used to identify position of sample sugar on chromatogram? So use locating agent. The student calculate the RF of a spot on chromatogram. Complete the expression for the RF value of a spot. So just write equation for distance traveled by spot divided by distance traveled by solvent. And then how could a student identify a sample sugar from RF? By compare with reference. Compare with reference. So if travel same distance means same substance. Sometimes not all substance in mixture can be identified from chromatogram produced. Explain why this happens. Because the spots didn't move from the baseline. If substance, for example, if substance didn't move from the baseline, you cannot measure RF, so you cannot identify the substance. Then another multiple choice. For example, methanol, which is CH3OH, and ethanol, C2H5OH, are miscible liquids. So which diagram shows apparatus that is used to obtain methanol from mixture of ethanol and methanol, mixture of miscible liquid used fractional distillation, which is going to be B. And then a mixture of sulfur and iron filling needs to be separated. Two solubilities of sulfur and iron feeling in water and carbon disulfide are shown in table below. So sulfur soluble in water, sulfur is insoluble in water, and iron feeling is insoluble in water. But sulfur dissolved in disulfide, carbon disulfide, which is another solvent, but iron does not dissolve in water and carbon disulfide. What are the possible methods of separating the sulfur and iron feeling? So first, if using water, you cannot separate sulfur from iron feeling because all substances are insoluble in water. So using water incorrect. So A and C incorrect. By using carbon disulfide, by using carbon disulfide, sulfur so separate as solution and iron insoluble so separate as residue. So it will be okay. So answer B or C. So both correct for carbon and using carbon disulfide. So using magnet, iron is magnetic, but sulfur not. So answer is gonna be B. Then the diagram shows three pieces of apparatus that are used for measuring the volume. What are these pieces of apparatus? So number one is correct A and B exclude measuring cylinder, so C or D. And then number two is gonna be purette. So answer it will be C, and pipette is 3. The four pieces of apparatus shown below are used in chemical experiments. Burette, measuring cylinder, pipette, and thermometer. Which statement about the apparatus is correct? The purette measures the volume of liquid added in titration. This is correct. Increases and melting point decreases. So boiling point increases. Remember, pure substance boil at exact temperature, which is 100, and freeze at 0, which is fixed temperature. So if adding potassium chloride or any other substance, water now is impure. So boiling point increases, so C, D incorrect, and freezing point decreases, so gonna be -3. So answer will be A. And then a student carried out an investigation on different plant extracts using paper chromatography. The experimental setup he uses is shown below. Where should he place the sample of plant extract? So, on the pencil line, place the sample on a pencil line, which is this one, or below the pencil line, or exact 1 centimeter above, or exact 1 centimeter below. So, on the pencil line, exactly. Then which method would work? Method 1 or method 2? Oh, this is a different question, I think. Okay, it would be different question. Okay. So the diagram below shows the apparatus a student used to separate product from a reaction mixture. What did the mixture contain? Contain water and ethanol. So miscible liquid separate by fractional distillation. Then question number 11. The diagram below illustrates the experimental setup to carry out distillation. What are the correct labels for points A and B on the condenser? So A, water in. Remember, water in from bottom and out from the top. So A is the water in and B is the water out. To be sure, condenser full with water, no air bubbles. Then, a sample of soil is shaken with distilled water. Draw diagram to show the filtration apparatus used to separate the soil from the solution obtained by shaking the soil with distilled water. Remember, soil is insoluble in water. On your diagram, label the filtrate and residue. So first, draw funnel and beaker. Then don't forget to draw filter funnel inside funnel. And then residue soil is going to be remain in filter paper, but solution can pass through the filter paper as a filtrate. Then the diagram shows a chromatogram obtained from color of three different X, Y, and Z. So the diagram shows a chromatogram obtained from the color of three different X, Y, and Z. So how many different red dyes are present in sweets? So remember, one red travels same distance and second red travels same distance. So only two. The chromatogram obtained from the four mixture P, Q, R, S is shown. What is the total number of different dye identified for mixture? So again, what is a total number of different dye identified in four mixture? You have R, Q, and P. So what is the total number of different dye? So first, this is the first dye, second dye, okay, third, fourth, fifth. So it's going to be 5. Okay, so what's the total number of different dye identified in 4 mixture? So 1, 2, 3, 4, 5. And then which dye on chromatograph is a pure substance? Only one spot. So it's going to be A. And then substance Q is tested using paper chromatography. The resulting chromatogram is shown. What statement is correct? Q is pure substance. No, 2 spots formed. The RF value of the lower spot is 0.25. Q is a mixture of at least 2 different substances. Yes. Q is a compound. Incorrect. So C is going to be answer. Thank you for watching, and I will record another class for you again. Thank you.